Hey, this is another tutorial thing. I said I won't do another, but I just felt this one was kind of needed. I've been helping a lot of people out. It's what I like to do, and I've been seeing a lot of reoccurring questions, and I thought it'd probably be better if I just make a little visual so I have something to point to. And obviously, this will be useful to other people who are not in direct contact with me and are just stumbling around on the internet looking for a way to fix something. So, yeah, basically, all resources and timestamps are available in the description, as you'd assume. And also, this video is split up into chapters. So if you have a very specific problem that this video covers, you should be able to just scroll across the timeline, find the part you need, and skip to it. I will be going over very, very basic stuff as well. I'm basically assuming to those watching that you don't or you haven't made a single avatar before, so I'll be going over simple things like converting to Quest and downloading SDK. But if you're an advanced user and have done this before, you can just skip past that, as I assume you should know. You've been on the internet long enough, you know how to do this. So, anyways, all I have to begin with is an empty Unity project. Nothing here. Just a scene that I'm currently in, which has nothing but a directional light. To start with, we should go to VRChat's website, log in, and here you'll see on the left side a download button. This is the download page for the SDK3 avatars. Well, avatars SDK3 SDK. You just click that, it'll download it. Once it's done downloading, you can drag it into Unity and it'll decompress. You click import, and that's that. Now that you've had the SDK imported, your project file is all set up and ready to make avatars. Back here, we're going to be using my Titanfall Asset Resource. This will be provided in the description, as I've already mentioned. This basically contains simple and basically any asset you will need from any of the Titanfall games. Titanfall 1, 2, the Titanfall 2 pre-alpha, Titanfall Assault, Titanfall Frontline, Titanfall Online, and Titanfall 3. I will not be going through the entire resource and showing you everything it contains, but so I will leave that up to you, but I will show some of the primitive things. First off, a README file, which basically just goes over a summary of what this is, as well as some legal information. This is a written setup guide, which will tell you getting correct textures, assigning textures to materials, getting rigs usable in VRChat, basically everything this video will go over. And I will most likely update this after this video is out, providing a link to this. This is also a changelog, so you can see when I last updated it, as well as what I add over time. I do not always update the changelog whenever I add individual assets, but when I'm doing larger updates, it is a good way to keep in touch on when it's being updated. The example/resources folder contains general information as well as hex values for emission textures for blue and red, for example, for pilots, titans, all that. Some videos, images, file names, all that basic stuff, as well as some example avatars and pre-made avatars that are already from the world. Eventually, my goal is to have every avatar project file featured as a Unity package you can download from this pre-made avatars folder, basically making the world open source. But do keep in mind, most avatars are quite old and are made in separate project files, so this may take a while. And on top of that, they also mainly use SDK2. So while their rig should port over pretty nicely, some other stuff like gestures and emotes may not port over quite nicely to SDK3. Back at the root, we can see each game that we can select from. This tutorial I'll be going over importing the Titanfall 2 phase shift pilot. it is under Titanfall 2, Models, Characters, Multiplayer Pilots. And here you can see I've already renamed all of the multiplayer pilots to feature names more commonly used in the game rather than their internal names. In other games, such as Titanfall 1, this may not be the case. Another example being the Titanfall 2 pre-alpha, where I still use their internal file names, which is why that example /resources folder can come in handy. Anyways, back on topic. Phase shift. Right click, download, and you'll have the FBX. This does not come with textures pre-applied to it. We will have to find those manually, and I will show that later. You can simply drag this into Unity straight away, though I do recommend creating a separate folder for all of your assets. The common misconception is that these models do not support full body tracking or regular tracking natively. This is simply not true. Source engine models do not import very well through the avatar editor that Unity provides for humanoids, but it is a simple fix that you can do either manually or automatically through a tool that I provide in my resource. When I applied this, it did not give me any errors. This may not be the case for whichever model you're using. Alright, now to get the textures. One really easy way to do this is to drop the model in the scene, or in Blender, or in any way to properly view the model and its materials. You will be able to click on the mesh and you can view all of the material names. These material names directly correlate with the texture folder names. Also, you will notice that these materials are grayed out and we cannot modify any of their properties. This is because we need to go into the Model tab, the Materials tab, and set Embedded Textures to External. That way we can edit all of these. And as long as the model in the scene stays blue, any changes we make down here should affect this. Unpacking it will stop that from happening. Okay, now that we know the texture folder names, it is Pilot Light Jed Male. And that's pretty much consistent throughout all of them. And then after that is what really identifies it. So gear, jump kit, body, hands, I think. And skin 01, because there are multiple variants for if you're wearing multiplayer camos, or if there is a single player character that uses the same model. Back in the resource, we're going to back out, and we will find a textures folder. The textures are stored locally in Google Drive along with everything else, and some things are only like this, like the camo masks and the camos, but I do highly recommend that you do not use this for generally getting textures. You can download the entire folder, but it can take a while and it'll have to zip, and Google Drive is just very janky in navigating all of this. So, if you click on this text file, it contains a link. I'm stumbling on my own words here. But this goes to a mega.nz re-upload of all of the textures, exactly how it is in Google Drive. Mega is pretty much all around a better file sharing resource, and you may have to log in or not to use a search bar. But we can search for our textures, so if we go back to it, Pilot Light Jed. Wait, that's P_light Jed. And there we go. We found all those textures, just like that. I'll select all of the skin ones, since they're the ones that I need. I guess I should also mention, I recommend downloading these as a zip, which is an option whenever you open download, this little drop down. This will keep the folders and their names, which is pretty useful whenever you're dragging them onto materials, as you could assume. And I will show you how to do that as well. You will have to unzip these, of course. Now that they're all extracted, I recommend dragging them into the materials folder. Okay. Now, try to match the material name. You can lock it by clicking this up in the top right with the texture folder. So, here, let me find a good material first, actually. Let's do the head. Pilot light jed male head V1 skin 1. We can change this to just a plain white so it doesn't affect our textures. And we just find that folder. This is it. And here we have all the textures we need. This is the base albedo. You can tell because it just has regular colors. This is the emission / illum map. It contains everything glowing. We can get a color that is used in-game from the resource as well, as previously mentioned, by going back into the example / resources folder, and right here at the top, illum hex values. Friendly and enemy. I'm going to choose enemy just for some diversity, I guess. Open this up. Oh yeah, I guess I guess I have to copy them all manually now. Thanks, Unity. 255, 120, and 32. And that's the hostile color for glowing stuff. Here is a specular map. You can tell it's a specular map because they're typically gray. Sometimes they do have colors in them. This is one of those scenarios where it does. But this is what's used for reflectivity. Oh, but you may want to change it to standard specular setup so that we can actually make proper use of a specular map. Do not leave smoothness at 1 unless you want your model to look overly reflective and awful. Lower it down to something more reasonable. Metal I typically keep around 0.6 to 0.7, in that range. Maybe I'll do a little lower on this one actually. 0.55 seems about right. Basically, judge it by the eye. If it doesn't look right, it's probably not right. Okay. This map is the, what is it? It's the occlusion map. It's also called ambient occlusion. It's basically pre-baked shadows. Drag it into the occlusion slot. You don't really see much happen, but it adds shadows, and it helps, especially with the specular map. Right here, we skipped it, you may have noticed, is the cavity map. By default, Unity does not have any shaders that I am aware of that properly use cavity maps, so it will be ignored. This last one is a normal map, despite its odd appearance. This is, I believe, a global normal map, and that's why it's yellow and orange and green rather than our typical purple ones. While this does work on PC if you drag it in and press fix, this will not work on Quest. But that's where I have a tool. A while ago, I wrote this as a simple way to automate parts of the porting process from Titanfall 2 Unity for VRChat fan content purposes. You can find it in the Titanfall Asset Resources example / resources. It is this, a Unity package file near the bottom, represented by this weird arrow thing. Drag it into your project and import. Now that you've imported it, you'll notice an extra button at the top called Titanfall Asset Tools. From here, the first tab contains a Check for Updates button, which can be pretty important since I do not update the one in the asset resource as commonly as I do on GitHub. But the tool we're looking for in this scenario is the normal map converter. This simply takes in yellow normal maps, and you'll be able to convert them. I checked every button because it replaces it and copies the input compression, exports it as a PNG rather than a JPEG, basically all the settings I need. You might want to copy them. But now you have, as you may have noticed, our normal map looks correct on PC, but this will also, as it is, if I change it back to default, this is now just a regular blue map, as you would expect, really. So this would also work on Quest, which is important because previously you would have to manually edit this in an app like Photoshop, or you would just ignore normal maps on Quest and leave your avatars looking far less superior than the PC counterpart. So yeah, our material's basically all set up. And that's that. Hey, I forgot to mention this, so I'm sort of re-recording this part, but in the textures as well, their default max size is 2048. This is actually smaller than most Titanfall textures, which are usually around 4096. I'm totally saying that incorrectly, but you can cry about it. But by changing this, you'll see the textures in full resolution. This is especially important for the normal map and the albedo map. It gives you a ton extra detail. These ones, actually, you could probably lower the resolution on without really risking much. Maybe not so much the illum map, but specular, cavity, ambient occlusion, you can probably lower those without losing much. Now, back to the rig. If you click on the model down in the project browser, I assume it's the proper name, and then up here you'll see these 4 tabs. Go to rig and press configure. If your Unity doesn't crash randomly, this is where we would set up the rig. Now that we're in the avatar editor, you'll see that the camera zoomed really far out. When you move the camera back in, the focal plane may not be very useful. So if you just press the middle mouse button, it'll focus it on the model and you can get a lot closer without it clipping. Anyways, to the important part, fixing up the rig so that it's properly usable in VRChat, including full body tracking. Hey, swag from the future here. I did not like the way that segment went, so I'm just gonna re-record it again. So yeah, let's set up the avatar. By default, usually it's looking somewhat like this. First thing to do, simple thing, select the top one. It's usually mapped to spine C. If not, just grab spine C over in this side is where it'll show your skeleton. Grab it and put it in the chest area, and then find upper chest and simply set it to nothing. So you can do that by spamming every key. The only option will be none. Press that, and you'll be good for the chest. Though on this model, your model may not have this. If it does, then cool. I have another problem with my spine, and that it is def C spine A has a bone length of 0. This is a really simple problem to fix, if you click on the bone that is the bone in question, uh, that's having this problem, it will select it, obviously. But down here, you'll see it has a length of 0 on all axes. You can manually move it just a very small amount, or you can go down here and set it to something absurdly small. I'm gonna do it not that small, but it doesn't have to be noticeable at all. It can look the exact same, but as long as y is not 0, it stops complaining. So here, I'll apply it, and you'll see scary error message goes away. Well, cool. Next up, this is a problem I'm pretty sure every model has, so pay attention. These two slots are the shoulder and clavicle slots. The one furthest out is the shoulder, the one further in is the clavicle. As you've probably noticed by selecting these slots, they're not exactly correct. In fact, shoulder mid shouldn't even be mapped to anything. So I'm going to start with the clavicles. By selecting the right clavicle slot, it'll select the right shoulder, which is pretty close. Def R clav, which is short for clavicle, drag that into the slot, and then drag shoulder into the shoulder slot. This will not mirror on the other side, so repeat the same process again for those shoulders and stuffs. Cool. Now you'll get some red errors in the scene that your character is no longer in a T-pose, and it'll point to your shoulders and say, that's the root of the problem. But yeah, just go down here, pose, enforce T-pose. Very cool. Unity satisfied. It's a little bit straighter, so I'm satisfied. We're all like that. If you have problems with the neck, just the neck rotation or anything, just check up here. The head slot should be set to neck B, not the actual head bone. Maybe a little confusing, but here's an example why. Also, funny thing, it mapped it to the right eyeball, so I'm going to clear that while I'm over here. The head bone is actually more of just a root position for all the things attached to the head to connect to. Oh, whoops. So for this case, oops. It's just the little raccoon tail jiggle stuff. On models that have faces like grunts, it'll just be their forehead or whatever. And mapping the head to the head slot is generally just gonna destroy everything. So remap it to neck B and make sure the bottom one is neck A. You're all good there. Now, this is another problem that pretty much every model has, and that's the fingertips are rotated, but more sort of hidden is that the middle finger and the ring finger are actually swapped with each other. So you see, I just clicked the middle one, and it is mapped to the ring finger slot. Sort of like the clavicles and the shoulders, we're going to have to manually drag these back over, including the children objects. So mid A, B, and C to the mid A, B, and C slots. It'll appear all red while you're doing it, and after you do it, they'll still be red until you complete both. So here, I'll put the ring slots in the correct areas. And bada boom, bada bing, all green over here. Though, in the scene, you'll notice, sort of like the clavicles, it's complaining it's not in a T-pose. I would say once you start working on your hands and beyond that point, do not enforce T-pose. Make sure it is T-posed prior to this point, because if you rotate the fingertips and stuff, and then you enforce T-pose, it'll just revert that progress. So yeah, don't do that. But now that we're actually talking about the fingertips, one way that I talked about in a previous video is to manually rotate it. That's one way to do it. It's iffy. If you scroll down to the transform, you'll notice these ones are pretty close to 0, but you'll see one that's pretty close to 80 or 90, somewhere around that. Just set that to 0, and it'll be perfectly straight. just like that. Or, if you followed my previous advice and got this tool thingy, there's a tool called the Humanoid Avatar Fixer, and it's in a pretty primitive state at the moment. I don't really update this tool too often anymore, but in the future, I would like to have the ability to remap bones, and so this entire process could be automated. But for now, it's basically just about the bone length of 0 problem that we already fixed, rotated fingertips, which we're just doing now, and Titan hands, which we'll get to. So yeah, everything should be set up pretty fine already. Just press autofix, and as you can see, it'll automatically rotate all of your fingertips for you. You don't have to go do anything, really. And just like the shoulders, again, you'll have to come over here and remap these again on the other side. Really simple stuff. With the tool, it's a little faster, and it's not that inconvenient. You get used to it. Now you know. Also, press apply and done whenever you're, well, done. Now I am going to briefly discuss how to properly set up a Titan rig, as it is a slightly different process. As you notice with my ion here, the fingertips are all spaced out, and it doesn't have a properly mapped head. You will also need to, or you may also need to remap middle fingers, ring fingers, rotate fingertips if those problems exist, as well as properly mapping the spine. But I assume that if you're working on a Titan, you hopefully know what you're doing by now. Anyways, one common question that I hear is what I do with the head and neck. Since Titans, if you look at them, they basically just stop at a chest. They don't have a humanoid style head above. So what do I map this to? And Unity even gets confused by this. Well, in Titanfall rigs, they actually do have neck and head bones floating above the Titan chassis, which aren't mapped to anything. They're simply there for humanoid models to properly show up in source, or to properly animate in source, I mean. But we can also use this for our own purposes of properly animating in Unity. And dragging those in, you'll see it's all correct and compliant. Now, if you do have floating fingertips like this, in my tool, you will find in the Humanoid Avatar Fixer a Fix Titan Hands button. This is experimental, I would not touch it, and it's basically only for BT. This, by default, is a pretty good spacing, so just try it out. And see, for Ion, it worked pretty dang well. If you want to do this manually, you basically just select on the bones and move them into the correct positions. Oh yeah, that's that. Now in the scene view, the cockpit doors aren't properly aligned, and you may also be wondering where to place the camera. Like, should it be where the data core is? All of that stuff. Well, I typically place the camera slightly above the cockpit, you may have noticed. And this has its benefits and drawbacks. One benefit is that you have a very clear view, and it's around where a humanoid head would be if a Titan were to have one. So it lines up with your shoulders pretty well, all of that stuff. Downsides are the offset from the head bone to the camera can be quite a bit, so looking up and down can move the viewpoint a lot. And opening the embark hatch can block the view if it's aligned that way. You may also be concerned about the fingertips floating in the scene view. Do not worry, we already fixed that in the avatar editor. Seeing it floating in the scene view is not a problem. In fact, if you were to apply an animation or an emote to this model, you will be seeing it animate correctly in this view. But anyways, back on topic, To fix the hatch, you will use the Titan Hatch Fix tool. Select the multiplayer Titan that you are using. I'm using Ion. If you're using a Prime variant, you would just select the default one as they have the same offsets. Go into the model, find the spine C bone. So that would be under hip, spine A, spine B, spine C. Once you have that selected, go back to the window and you'll see this button reappear. Click that and it'll fix the hatch for you. Not easy. Whew, this is getting exhausting for me. But anyways, now to get this working on Quest, what you'll have to do is to place the avatar descriptor on the model. You should already have this, hopefully. Go to your control panel and press the switch build target to Android button. This may take, it'll convert your entire project file to work on Android, which is the platform that Quest works on. Or runs on, I mean. Once your project is done converting, you'll notice a bunch of new errors and you won't be able to upload it to Quest. This is because Quest does not allow PC shaders at all, including the built-in Unity ones. You have to use VRChat provided shaders, which come in your SDK. So what you'll need to do is go to your materials folder, select your materials, change them to VRChat Mobile Standard Light. If you have emission, re-click that. Now, I just did this to all of my materials, even though I did not even texture these ones. But for this model, this is generally a decent process, as I don't really have any fancy stuff that's going on. They all work the same way. You will need to go into it and basically redo your specular setup. Try to recreate your specular setup in here using the metallic and smoothness nodes. Titanfall does not use metallic maps. Titanfall 1 did a little, I think. Maybe wrong though. So just kind of judge it. Make it look good enough. That right there, that's good enough. But as you notice, normal maps are rendering correctly, even on Android. Very nice. Now that you've converted your materials, you can reopen that control panel and notice all of those problems are gone, and you can upload it to Android. Cool! But you'll also notice that it has reevaluated your performance rating for Quest users. And it will mention that your avatar will not be shown by default. If you're unfamiliar with Quest, what this means is if your rating is not a green icon in the bottom two ratings, then it will automatically be hidden. People can still see it on Quest. It will still be available to be viewed on Quest, but they will have to click on your social menu to show your avatar. It will be hidden. From my experience of playing on Quest, this was typically common practice to do anyways, at least in private lobbies. Public lobbies, I assume they're more cautious because people can be weird and want to crash your game. But yeah, you can upload this to Quest, you can go back, upload it to PC, you can upload it to PC, then try to port it to Quest, whatever. You will have a fully functioning Titanfall avatar in VRChat. Enjoy!